Bonsuelo, athletes. Today we're going to do long division. So the last time was kind of like a simplified division, but this is the main type of polynomial division. Okay, before we get to polynomial division, I just want to review regular division. So let's divide 457 by 13. Okay, so you put the 13 and the 457 in the little division symbol there. And then what do? You ask yourself this. What times 13 will give me 45? Notice, you don't have to look at the whole 457. It's what times 13 will give me 45 or something less than 45. Okay, well, 3 times 13 gives me 39, so I'll use that. But notice, you're not looking at the entire 457. You're just looking at the part that you need, essentially. So we'll put the 3 on the top, and then we'll multiply the 3 times the 13. And the 3 times the 13 is 39. Now what do? And I know this seems really stupid, but we subtract the whole thing. And to emphasize that we're subtracting the whole thing, the whole 39, I'm going to put the 39 in parentheses. I know it seems kind of unnecessary, and yeah, for this problem it is unnecessary, but I'm still going to do it just to emphasize it. Okay, then let's subtract, and you get 6. Okay, then we drop down the 7. And then we ask kind of the same question, what times 13 will give us 67? Okay, so, it's a little bit of guess and check, but basically you get 5. Then we'll multiply 5 times 13, and that's 65. And again, we'll subtract the entirety of the 65. And then we'll get 3. Okay, at this point, there are 3 things that you can do. The first thing you can do is keep dividing using decimals. In other words, put a decimal after the 7. Okay, that's your first choice. Or that's one choice, not necessarily the first one. The other thing you can do is you can write the remainder as a fraction. So we can say this is 35 and 3/13. Okay, that's another choice. And the third choice, which is the lamest choice of all, and which I don't want you to do, even though I think Alex does this sometimes, so you have to do it for them, but is put 35 remainder 3. Okay. Well, which one am I going to emphasize here? This one. Okay. Plus, I just want to point out something. If I had to stick a sign, mathematical symbol between the 35 and the 3/13, what would it be? It wouldn't be multiplication. We're not multiplying 35 and 3/13. What we're doing is we're adding 35 and 3/13. Now, you don't have to write that. You just write 35 and 3/13. I just want to point out, that's what you're actually doing. You're actually adding them, okay? But we're going to pick that method where we write the remainder as a fraction over the divisor. So basically, again, what are we talking about here? This is the dividend. This is the divisor. This is the quotient. And then this is the remainder. Okay. Now let's see how that works with polynomial division. Basically, we're going to have the same idea. Okay, this is what we're going to do. When I figure out what goes on top, like up here, where the 35 is, I don't have to look at the entire 45 or 457, just the part that I need, right? Well, I'm going to do the same thing kind of down here. To figure out what goes on top, what goes up in this area right here, okay? I don't need to look at all of it. I just need to look at the first term above the divisor and the dividend. Okay, so what times 3x will give us 9x cubed. It's kind of like up here. I asked, what times 13 will give us 45 or something smaller than 45? Okay, so what times 3x will give us 9x cubed? And what will give us that is 3x squared. Okay, now that I've got that, what do? You multiply, right? Once I wrote the 3 up here on the top, sorry, I should have erased that. Once I wrote the 3 up here on the top, I then took the 3 and multiplied it by the divisor. So I'm going to do the same thing here. I'm going to take this 3x squared and multiply it by the entire divisor. So I have to give the 3x squared to both the 3x and the 4. So that's going to give me 9x cubed plus 12x squared. Now, if you're going to make a mistake, this is where it's going to be. What do you do next? You subtract. So this is what people do. They put a minus there. Wrong. Okay? Because we have to subtract the entire quantity we've got there. And do you need parentheses there? Yes, you need parentheses there. Okay? I did it up here on the top just to emphasize it. Here you absolutely need it. So we take 9x cubed minus 9x cubed is nothing, and 9x squared minus 12x squared is minus 3x squared. Then I drop down the 5x, just like I dropped down the 7 up here, right after I subtracted 45 minus 39 and got 6. Then I dropped down the 7, and I did it again. So I dropped down the 5x. I do this again. What times 3x gives me negative 3x squared minus x? So now I take that, negative x, and I multiply it by each one. So I get negative 3x squared minus 4x. And then I subtract the whole quantity. And negative 3x squared minus 3x squared is nothing. And 5x plus 4x, which is minus a negative 4x, is 9x. Then we have plus 4. And then I do it again. What times 3x will give me 9x plus 3, and then I multiply that by the divisor. So you're always asking, what times the first, to figure out what goes on top, what times the first term of the divisor will give you the first line, or not the first line, sorry, but the first value in each line. Okay, so what times 3x will give me 9x, 3. So now I multiply the 3 times 3x, and we get 9x plus 12. And then again, I subtract the whole thing, and you get minus 8. Now, what do we do with that? You know, Alex is kind of lame. It probably has you go remainder negative 8. No, that's not what you want to do. This is what it really is. I mean, do it for Alex if they make you, but 3x squared minus x plus 3, and then minus 8 over 3x plus 4. So up here on the top, what did I do? Remember on this, the second option here, I took the remainder and put it over the divisor, 3 over 13. I'm doing the same thing here. I'm just taking the remainder and putting it over the divisor. Okay? So when you take this whole thing and divide by this, you get that right there. Okay? Now, it's just a matter of looking at examples. Little longer problem here. So, again, what times x gives me x to the 4th? What'll be x to the 3rd? So it's what times the first term in the divisor gives me the first term in the line that I'm dealing with. And in this case, I'm just dealing with the x to the 4th power. Okay. So now I multiply that thing, x to the 3rd, times the entire divisor. So x to the 3rd times x is x to the 4th, and then minus 3x x to the third. Okay, now I subtract. Now notice both drop out. Both drop out. See, normally only one drops out. Like up here in this first problem, when I subtracted the 9x cubed minus 9x cubed, that dropped out, but the 9x squared plus 12x squared, the x squareds didn't go away. So since only one column had dropped out, the cubes, I brought down one value, the 5x. Okay? But here, notice, both columns, x to the fourths and x to the thirds, go away. So I have to bring down two things now, the 7x squared and the x. And now I do it again. What times x gives me 7x squared plus 7x? Multiply 7x squared minus 21x. And I subtract the whole quantity. And then we get 22x and drop down the negative 10. Because only one thing, the x squareds dropped out. So I only have to bring down one term. Okay, let's do it again. What times x gives me 22x? It'll be plus 22. So again, it's what times x gives me 22x. That's what I'm asking. But once you have that 22, you have to multiply that by the entire divisor. So we have 22x minus 66. And now I'm going to subtract the entire quantity. The 22x's go away, and we're left with 56. So what does that give me? It gives me x cubed plus 7x plus 22 plus 56 all over x minus 3. Okay? Now, about the only other thing I'm going to show you that you have to be careful of is in problem number 3. Notice we have an x to the fourth and we have an x squared, but we're missing an x cubed. Okay, you have to supply the x cubed in the dividend. And notice, how many x cubes do you have? You have 0x cubed. So we have 2x to the fourth plus 0x cubed minus 4x squared minus et cetera, et cetera. You have to supply that 0x cubed. Okay? And once you do that, okay, it's just the same thing as all the other ones. You know, what times x will give me 2x to the fourth, multiply. Basically, what do? You multiply, subtract, multiply, subtract, multiply, subtract. So what times x gives me 2x to the fourth? It's 2x cubed. Then I multiply and subtract. So we get 2x to the fourth plus 2x cubed. That's the multiplication. Then we subtract. Okay, the 2x to the fourth go away and we get negative 2x to the third, and then drop down the 4x squared. Okay, what times x now will give me the negative 2x cubed? Okay, so that will be negative 2x squared. And now we multiply and subtract. So we have negative 2x cubed minus 2x squared. And now I subtract the whole quantity. And again, you should be trying this on your own before you see me do it. So that the x cubes go away, and we have negative 4x squared plus 2x squared. So that's negative 2x squared. Now we'll drop down the 5x, and we'll do it again. So what times x gives me negative 2x squared? A negative 2x. Then we'll multiply and subtract. So we have negative 2x squared. So we're taking the negative 2x and multiplying it by the entire divisor, x plus 1. Negative 2x squared minus 2x. And now we'll subtract the whole quantity. The x squareds go away, and we have minus 3x, because it's negative 5x plus 2x, and then plus 1. And what times x will give us? What times x will give us negative 3x? That's how you figure out what goes on top. Okay? And that would be a minus 3 Once I have that, I multiply that by the entire divisor. So we have minus 3x minus 3. Subtract that quantity, and we get 4. Okay? So what's the answer? Now, on all of these ones up here, I kind of rewrote the whole thing. You don't need to do that. You can just at the top put plus 4 over x plus 1. That's fine with me. Or you can rewrite it all if you want to. Okay? All right, let's take a look at another one. Okay, here we're missing an x squared in the dividend, so I put a 0x squared. Also, we're missing an x in the divisor, so I have to supply the x. So we're missing the x cubed, x squared in there, so I have the 0x squared, and we're missing the x, so I have a 0x in the divisor. Okay, and other than that, you just keep doing the same thing. Once you get that, I mean, it's not going to change. So what times x squared gives us 2x to the fourth? That'll give us 2x squared. Then we multiply and subtract. So we have 2x to the fourth. And you have to be careful here. A lot of people make a mistake when there's a 0x in the divisor. I'm not really sure why, but I know people do. So 2x squared times 0x gives you 0x cubed. And then we have 2x squared minus 3 is negative 6x squared. And then we subtract that entire quantity. Okay, so the 2x to the fourths go away. We have negative 5x cubed. And 0 minus the negative 6 is plus 6x squared. And one term dropped out, so we dropped down the 7x. Then what times x squared will give you the negative 5x cubed? Again, you just keep asking the same question. And so what times x squared gives us negative 5x cubed, and it's negative 5x. And then we'll multiply that by the entire divisor. So we have negative 5x cubed plus not negative 5x squared, but 0x squared. And then negative 5x minus 3 is plus 15x. And we'll subtract that entire quantity. The 5x cubed, negative 5x cubes go away. You get 6x squared minus, not plus 22x, but minus 8x. And then we'll drop down the 8. And again, what times x squared will give us the 6x squared will be plus 6. Then we multiply and we get 6x squared plus 0x, not 6x, but 0x, and then minus 18. Then we subtract that entire quantity. The x squareds go away, and we get minus 8x, and negative 8x plus 18x would be plus 10. Now, at this point, you can do one of two things. Probably the simplest thing to do is this, and I'm going to write this down on the bottom, okay? And just listen for a second. 2x squared, you could write on the top, though, minus 5x plus 6. Now, what you cannot do is this, minus 8x plus 10 over x squared minus 3. Why? Because that would make the 10 negative also. Okay? So if you're going to put, well, I'll show you probably what's the best thing to do first. Okay? Probably the best thing to do is just use a plus and put negative 8x plus 10. Take the entire remainder and stick it over the divisor. Okay? That's one possibility. That's probably about the best thing to do. The other thing that's possible, I'm going to probably erase this, is you can stick the negative here out in front. Okay? But in which case, you have to factor a negative out of the numerator, and so this would become a negative 10, because that'll give you negative x plus 10 once you distribute this negative that's here. Okay, that usually kind of confuses people. So I would say probably your best bet is keep this positive, just put a plus there, and then it's minus 8x plus 10. Okay? All right, now, just want to remind you about terminology here. You have the dividend is divided by the divisor, you get the quotient remainder. How are these four things related in the equation? So like here, we could say this. Well, 7 is equal to 2 times 3 plus 1, right? Hopefully that's obvious. So what are we saying? The dividend is equal to the divisor times the quotient plus the remainder. Okay, and that's all this statement here says, that the dividend is equal to divisor times the quotient plus the remainder. Okay? All right, one last thing. Taking a look at this, okay, I'll copy it off down here, that we had 7 divided by 2. Okay, is 2 a factor of 7? And hopefully you'd answer no, but the question is why not? And basically it's because 2 does not divide evenly into 7. Okay, well, how do you know 2 doesn't divide evenly into 7? Because there's a remainder. Okay? If there's a remainder, then the dividend does not divide evenly into the divisor, and therefore the dividend is not a factor. Sorry, the divisor is not a factor of the dividend. So let's say I take this. Let's say I take 14 and divide by 2. Okay. Is 2 a factor of 14? Yes. Why? Because there's no remainder. You could say the remainder is 0. Okay? So going back and looking at all these problems, was 3x plus 4 a factor of 9x cubed plus 9x squared plus 5x plus 4? No, it's not. Why? Because there was a remainder of -8. Here, is x minus 3 a factor of x to the 4th minus 3x cubed plus 7x squared plus x minus 10? No. Why? Because there's a remainder of 56. X minus 3 doesn't divide it evenly. Okay, is x plus 1 a factor of the dividend here? No. Why? Because there's a remainder of 4. Is x squared minus 3 a factor of the dividend? No. Why? Because there's a remainder of negative x plus 10. So if there's no remainder, or you could say if the remainder is 0, then the dividend is a factor of the divisor is a factor of the dividend. Okay? It's only if there's a remainder of 0. Okay, that looks like it's the end of this incredibly interesting lesson. Hope you got it. Might want to, again, try those on your own first before you actually watch me do it. But I guess if you're done with this video, it's too late for that now anyway. Have a good day, everybody.